What's up, you data friends? It's Yanis here and welcome to my channel. In this video, we are going to go over a practical example of an SQL test that you might get in your interview. And more specifically, we are going to attempt to answer these 6 questions under 20 minutes. So in this video, I'm going to go over question by question, as you see over here, and try to explain the methodology behind answering each question. If you want to practice with me, I'm going to have both the raw data and this code in my GitHub page, so feel free to download it and practice with me. If you don't have SSMS installed, then you can follow this link over here, or if you want a full SQL tutorial, you can follow this link over here. And before we jump into this video, let me just say that if you're passionate about data analytics and data science, then please consider liking this video, subscribing to my channel, and enabling notifications for my future videos. Right, starting with the raw data we have, if I select all of these 3 tables, you can see that we have 3 tables. The first one has information about the cars and their retail price. The second one has information about the used price per car. And the third one has additional information about our cars. So this is the third table. As you can see, index is our key column that we are going to use to join all of them together, which we are going to get a join question 100%. Right, going down to our test now, you can see that you have 6 questions in 20 minutes, which means that you have about 3 minutes plus per question. Also, the first thing you should do as soon as you get your test is to try and familiarize yourself with the raw data, which is what we have just done a second ago. Right, I'm going to come down here now and start answering the questions. The first question says, what is the average retail price per model for 2023, order descending? So if we check our raw data, we can see that model comes from the first table, retail price comes from the first table, and also the 2023 is the year which comes from the first table. So we are only going to use the first table to answer this question. I'm just going to copy it quickly, paste it over here, and here I'm going to say select model, comma, AVG, which is the average, then I need the retail price like this, then say as AVG underscore retail price from our table, and then over here I'm going to say where, and in the where I'm going to add our condition, which is year equals 2023, and then I also need a group by, and then the group by is going to be by model, so copy model, paste it over here, run this, and we can see the average retail price per model. The last thing we are missing is the order by, and then I'm going to say by the average retail price, and then descending. Descending is actually the default, but I'm just going to specify it. There you go. You can see that we have the average retail price per model descending. Something to be careful here is the column year. If this column did not have a type of integer in our table over here, then this code was not going to work. We would have to add the codes over here like this if it was not type integer. In order to check now if this code worked actually, which it did, we have just run it, but we can also bring year over here. So we can visualize, let me add year. So we can actually visualize that it's just 2023. So if we run this, you can see it's just 2023. Right, moving on, we have the next question, which says, what is the total retail price per make and cylinders for all-wheel drive cars, order descending? Now, if we select all of our raw data to identify the columns we need the make, which is from the first table. We need the cylinders, which is actually coming from our third table. And then we also need to filter all-wheel drive cars, which is coming from the third table again. And we need to use this drivetrain column. To do this, we basically need to join the 2 tables together. So I'm going to start with our first table. So I'm just going to copy this quickly, paste it over here. This from is going to go down here. This is going to be our first table. We need to select the make. So over here, I'm going to copy and paste, use make. we need to sum the retail price. So I'm going to remove the year and I'm going to sum this retail price. However, we also need cylinders, which comes from the second table. So over here, I'm going to run a left join. I am going to select everything from our third table, which is actually going to be our second table here because we don't need the second one. I'm going to add it into brackets because I want to filter this table first. And I'm going to select everything from this table where, and over here I am going to add this all-wheel drive condition. So I'm just going to say where drive train, which is this one, equals, and then I'm going to say all-wheel drive cars. There we go. So this is our table B now. And from B, I'm going to say B actually like this. I actually need to join them too before I return the cylinders. So I'm just going to say on A.index equals B.index. And this is the key we're going to use to join them together. Actually, index, I'm going to add it in square brackets so I don't get any errors. There we go. And at the top, we also need to return cylinders. So I'm going to say B.cylinders. We actually don't need to specify where they're coming from because we have distinct column names. However, it's always good practice to specify where every column comes from. So this is from A, this is from B, this is from A. This is my table A, left joining, table B on A equals B index. And down here, I need my group by. So I'm just going to say group by A.make and then B cylinders. And if I run this quickly, I think also means the order by descending. So I need my order by. And then the order by needs to be by the sum of retail price. I actually have to change this to sum because this is the sum. And then if we run this, oh, actually it's descending, sorry, it's the default, but it's still good to add it in. And then if I run this, you can see that we have the make, we have the cylinders, and we also have the sum. Something to notice here is that for some makes, we don't have a cylinder join. This means that there is data in table A, which is this one, that does not exist in table B. Assuming we want to remove any of these nulls or replace them with 0, we can do two things. If we want to replace them with zeros, we can say over here is null and then open brackets, comma, 0, close brackets, and then the comma. And then this is going to replace them with zeros. There you go. We actually need to say as and then the column name, cylinders. Or we can say in our where clause down here, where, and then B.cylinders is not null. B.cylinder is not null. And then let's say we didn't want to add this is null. So I'm just going to move this like this and then comment this out. And then this is B.cylinders. There you go. B.cylinders like this. If I run this now, we are not going to have any of those null values. So I'm just excluding a lot of the data. It's up to you how to do this. I'm just showing you a lot of different ways that you can answer the question. Right, moving on to the next question. It says, show the average used prices per model and year for cars that have more than 500 horsepower. We do not want null values. So you can see here it specifies that we do not want to see the null values. Over here it doesn't specify, but we have added it anyway. Right, to do this, I'm going to start with our first table. Again, we need to have a join here between A and B and maybe C because used prices come from our second table. If I select all of them, there you go. Used prices come from here, and also the horsepower comes from our third table, which is this one over here. So we need to join all three together. Right, let's start. So we need to say select, sorry, over here. So select used prices per model. So we're just going to say A.model, comma, then we need the average used prices. So I'm just going to copy this. And then over here, I'm just going to say AVG and then used prices, which is going to come from B like this. And then I'm going to name this as AVG, and then use prices per model and year. I actually need year, which is coming from A, so I'm just going to say A dot year, capital, and then year again is nice to have capital. So model year for cars that have more than 500 horsepower. So let's do the joins now. I'm just going to say from over here, this is our table A, like this. And then we need our table B, which is going to be the used prices. So this one, and this is B, and then I need to join them on index like this, on A.index equals B.index, and then I need another left join, which is going to be our C, which is going to be this car info. I'm just going to copy it from here, paste it. Now this table is C. Both of them going to join on index, on A.index equals C.index. And then from our car info data, we want to limit it to cars that have 500 plus horsepower. To do this, we can either add this condition within our C table, or we can add it outside of our C table down here. So I'm just going to add it in. So in here, I'm going to say where horsepower, which is this column, is more, like this, and then we need 500 horsepower. However, this is a text, so we have to clean this first before we apply a calculation on it. To do this now, we need to say left, like this. So left, open brackets. I need to select the first three characters, which is the horsepower number. And then if I select this quickly to see if this worked, you can see that all horsepowers now is more than 500, which means it works. So down here, I need a group by, and then I need my model and my year. So copy, paste it. I'm missing a comma here. That's why it shows it's an error. B.use prices, it cannot find it. It says, oh, I've used, no, this is correct. B.use price, it should be working. What is it? Use price? Yeah, that's fine. Use prices, average use prices, that's correct. Per model and year, and then cars that have more than 500, that's correct. I still need to add the where is not null, so it's correct. So over here, I need to say where, and then say B.horsepower. So B.horsepower is not null. And then I can actually bring B.horsepower. Oh, actually, this is C.horsepower. Sorry, it's coming from C. And then I can also bring this up in the top so we can visualize it. So it's not asking us to, but let's do it. Let's add it over here too. And then if we run this quickly, you can see that we have the model, the year, the horsepower, which they didn't ask, but we just brought it to check if it's more than 500. And we also have the average use prices. However, we still have null values here. So we need to add an and then say B.use price is not null. I'm missing n. So B.use price is not null. If we run this again, we can see that we have answered the question exactly as they have asked. And another thing we can do is that we can order it by, and then let's order by the average use price, like this. It's descending by default. There you go. So we have the model, the year, the horsepower, which is more than 500, and then the average use price as the question is asking us. Right, moving on to the next question. It says, show the top 10 models and make in terms of highway fuel economy that have a retail price less than 70K. We do not want null values. Now, if we select all of our raw data to see which columns we need from each table, we need the make, which is coming from the first table. We need the highway fuel economy, which is coming from our third table over here. And we also need the retail price as a condition, which is coming from our first table. Right, we're going to start with our first table. So I'm just going to copy this, paste it down here. We are going to say select and then say models, comma, and then do we need make, models and make? Yeah, we need make too. So models, comma, make from our table. And then we also need the highway fuel economy, which is going to come from our second table. So I'm also going to bring it over here just to visualize it quickly. So highway fuel economy over here is actually model. This is coming from A, this is coming from A, this is going to come from B. Let's run our joins now. So this is our A, then our B is going to be this table over here. We actually need a left join, then this is our B. Then we also need to join them on index. So on A.index equals B.index. And then in the where clause, we need to say that retail price is less than 70K. So I'm just going to get retail price from over here. So where A.retail price is less than 7123. So 70K, this is A with lowercase. And then we also need to be able to see the number, right? So if we run this quickly, you can see that this is not a number. So we cannot really do top 10 in terms of the minimum highway fuel economy. To do this, we can say left over here and then take the first 2, comma 2, like this, remove the space, close this, and then say as highway fuel economy. So if we run this again, we can see is a number, and now we can actually aggregate this. So we can say order by over here, order by minimum. If we add minimum here, I think we're going to have to do a group by 2, but let's test. And let's do minimum this, like this. Actually, yeah, we do need to aggregate it because look at all these Audis and these models. They need aggregation. So we need to add this mean over here too. So minimum left, comma 2, as over here it needs to be minimum. That's good. And this is the same as this one. Let's run it. There you go. We are missing the group by, so let's add the group by. So group by, and then we need these two. And then let's run it. There we go. We have the model, the make, and then the minimum highway fuel economy. Now for this one, we can either replace it to 0 or we can completely remove it. Over here, it says we don't need them. So we're going to add it in our where clause. So I'm going to say end b.highway fuel economy is not null. And then let's run this. There we go. So we have the model, the make, and then the minimum highway fuel economy. And now we can say top 10 because we only want the top 10 models. So if we run this again, there you go. We have the top 10 models in terms of minimum highway fuel economy. Right, moving on to our next question. It says, show all the cars that do not have used prices data. So this is actually something you're going to get a lot as a data analyst or a data scientist, is identifying what data does one table has that the other table does not have. So this one is asking us to check the first two tables because used prices is the second table and then the data for the cars exists in the first table. So what we need to do over here is that we need to say select all. So select all from our first table where the index is not in our second table. So if we select all the indexes from our second table, so I'm just going to say select distinct index, copy and paste from our second table. And if I select this now, this subquery has all the indexes that the second table has. And what the whole query is going to do is going to select everything from our first table that the index does not exist in the second table. So if I run the whole thing quickly, we get an error, select all from where index is not. Oh, this error is because we need is not in, sorry, is not in. It's actually not in. We don't need the is. There we go. So all these cars now, 1,174, I don't know if you can see it because I'm on the way. We have all these cars that do not have a used price. And if we manually check it quickly, number 17, 18, 19, 20, if we select everything from this table, you can see that we are missing 15, 16, 17, 18, which is these indexes that we get over here, 17, 18, 19, and then the second table does not have that data. Right, and the last question says, show all the data that exists in cart info but does not have a retail price. So it's a very similar question. We need to test all the data that exists in this table and it doesn't exist on this table over here. So I'm just going to copy this quickly and then paste it down here. I'm going to say select all from cart info, like you see, where, and then I need a subquery, and I'm going to select the distinct indexes now from our first table, because our first table has the retail price data. So I'm going to copy this, which is our first table. I'm going to say distinct index instead of all from our first table, where retail price is not null, because it's asking us to show all the data that exists on this table but do not have a retail price that comes from table A, from this table. So where retail price is not null, so if we select this subquery to quickly test it, we can see we have all the indexes now for cards that have data, so where the retail price is not null. And then if I run the whole thing, oh, I haven't added the index is not in, so I'm missing this, index is not in. And then if we run this, we have about 48 rows, again you can't see it but I can, that exist on our cart info table but do not have a retail price which comes from our first table. Again, these two questions are something you're going to be doing a lot as a data analyst and a data scientist, and this is why they are going to test your knowledge on these things in an SQL test. Right, so this is it for the test. We have answered all 6 questions. I think it took us more than 20 minutes, but it was because I was explaining them and I was also giving you alternatives. Let me know in the comments below how long it took you to complete this and if you thought it was easy or difficult or average. If you have enjoyed this video and you feel that you've gained enough value out of this video, then I would really appreciate it if you click the like button, subscribe to my channel and enable notifications for my future videos. If you have any questions, let me know in the comments below. Otherwise, I'm going to see you in the next video.